you have AA is equal to AD. Remember the second problem of your exam. When you have a pulley system, you need to be careful.
Well, the acceleration of B is going to be proportionate to the acceleration of A.
Right. But by how much? 3, okay. So can we prove it? Yeah. That's true. You're right about that. The 60 degrees might get in the...
So the vertical component might be true?
Oh, no,
Well,
so
I don't know. Well,
you'd have to do a
I would
summation
say
of forces.
we have to prove it.
Well, let's just get the tension. Can we just
The
solve for the tension?
The tension for the rope. How could you solve for it?
Well, some of the forces, if you have an x and a y coordinate.
So I can have on SA like this, for instance, for B. So it would be your on SB, I'm sorry. So you can have also y component, yes. So
Sine 60 times the acceleration due to gravity.
the acceleration of B, well, we have to be careful. That would be the acceleration if B was only subjected to the weight on the normal. But you have that force here. You see, if you, let's study what B is doing. So yeah, let's, well, let's write down the equation, and you're going to see that you're close, but we need to include the tension. So I can write for B, so that I have the sum of the forces. So let me do it fully here, plus the weight. So it's equal to the mass of B times E. So now I can write the SB component of it, that is along the XB axis. So what do I get? Well, the tension is going to be the tension along SB, and positive. So I'm writing the component of that equation along this axis here. Then, what is the component of the normal along the SB axis?
0.
0. How much do we get for the weight? What is that angle? 30 degrees, yeah. So what is the component of the weight?
W cosine 30.
Right. So it's going to be on its minus, because it goes in the negative direction. So minus W B, let me just say B, cosine 30, or if you want, I can put a sine 60, because it's the same. This way we're going to get the sine 60 that we are talking about here. So when we get this is equal to md times the acceleration of B, because the acceleration is of course along the SB axis. So you see, if you solve for the acceleration here, well, this is going to be mvg, so you would get t minus mvg sine 60, it's equal to md ad. So if the tension is 0, then you would get g sine 60, as you were saying. So this is what would happen if you were to cut that rope. If you cut that rope, the block slides down with an acceleration of g sine 60. But here, of course, that's not the case. You have the tension. So we know everything except two quantities, the tension and the acceleration of B. So Remember we did that because we said, oh, we need the tension to figure out what's happening for A. So we did all of that thinking, oh, we're gonna get the tension. But we cannot get the tension yet. So there is something else to put in there.
Well, the tension on the rope gives on B is the same as the tension on one of those ropes, because you can see that that lever just, that pulley, top pulley just redirects the direction.
Okay, so we get that. All of this is equal to T, right?
And then you can find T in terms of the mass of A.
So let's write down what is happening for A, okay? So we're gonna get for A. So you see here what I'm doing when I'm solving the problem on the board. I'm making all kinds of choices that are important. So I chose an axis here that is going in the direction of the motion. That's always much easier because your acceleration is going to be positive. If not, it's a bit of a pain. And here, choose for A an axis also that is going in the direction of the motion. And you can, of course, choose another axis going the opposite way, but it's going to make your life harder. So for A, we can write down, so as vectors, when you write it down as vectors, it should be always pluses. Sometimes I see that when you write that, you're kind of writing a vector equation thinking already in terms of components. You don't want to do that because it might trick you when you go to the components. So when you add vectors, it's always positive. F net is the sum of the forces, never the difference between them. But of course, now if I look at the SA component, which is all of it here, what do we get? Well, the weight is going to be MAG. What about the tensions? Minus 3 times T. And it's equal to the mass of A times the acceleration of A. So what is it that we don't know here? The mass of A and the tension. So how many, and these are the two equations that we have, this one and that one. So how many unknowns do we have between these two equations? 3. So no matter what you do with them, you cannot solve the problem. You need a third equation.
Oh, you can use the SAT equals 1/2.
Well, we used it already by saying that we know the acceleration.
Well, we can link the accelerations. We can say that the acceleration of one of A is some proportion of acceleration of B.
Right. So you need to use that kinematics, that constraint, I should say. That is, when A moves, B is going to move as well. So there is a constraint between them. And it is because the length of the rope is not changing. So we need to use that. So we need to figure out what the constraint is going to be. And it's going to be our third equation. It's going to link these two quantities. And then we're going to be able to solve the problem. So what is the constraint? So we can say the length of the rope is constant. So we need to use our axes. I'm going to have on AC like this, and I have on SB like that.